This is a 3D Blender model of our current working prototype. We have set up a circuit inside a box to create dark environment. Inside this, we have placed a water container, and on one side we have attached three LEDs, red, green and yellow, which will blink sequentially. And on the opposite side we have one LDR and another LDR on the adjacent side. Let's see how the LEDs blink sequentially. First the red LED, then green and yellow. In this way, the LEDs will blink sequentially and the light will pass through the water sample and fall upon the LDR. The light will pass directly through the water sample and fall on the LDR, indicating that the sample is clean. And if the rays get deviated because of the presence of particles in water, then the deviated light will fall on the adjacent LDR. Hence, detecting the presence of microplastics in water without any prior sample preparation, data from the LDR is sent is over the machine learning model using Arduino. Now let's take a look at how the real life working of the model takes place.
Hello, we are Team Micro Guardians, and our problem statement is the detection of microplastic in water. The idea behind our model is to use a set of LEDs of different wavelengths and LDRs. A water sample is placed between them. When light from the LEDs passes through the sample, LDR captures the scattered light. Based on the deviation of light, numeric values are generated in real time and displayed on the serial monitor. To begin with, we have tested our setup with clean water sample. Now we'll create a dark environment so that we get accurate readings. Red LED shows 269 and 105, green LED shows 263 and 105, yellow LED shows 7 and 46. These readings act as a baseline reference values. Using these baseline values, we plan to train a machine learning model, specifically a support vector machine, which will help classify the incoming data as either clean water or water containing microplastics. Next, we place a water sample containing plastic particles. Again, the LED shown light through the sample and the LDR detect variation in scattering. On the serial monitor, now we can see the new values. The new values are red LED showing 202 and 110, green LED shows 190 and 11, yellow LED shows 32 and 46. This shows how the reading changes in real time when microplastics are present, and these variations can be processed by our machine learning model for classification. This is our very first prototype. In future, we aim to implement the system using an ESP32 microcontroller, photodiodes for higher accuracy and sensitivity, and even laser source instead of LEDs for greater accuracy. Our model is portable, cost effective, and provides real-time data, making it highly suitable for field application in microplastic detection.
This is our 3D standalone microplastic sensor model. It is in the shape of an open and closable cylinder with a detachable water container. It has LEDs and LDRs connected on the inner surface of the cylinder with an ESP32 embedded on the upper lid that controls the circuit and transfers the LDR reading data to the software through its Wi-Fi or Bluetooth module depending on the availability of the internet. And this is how the model will look on closing. No wires on the outside, a complete portable microplastic sensor made under just 2000 rupees.
This is the interface of our website where we can see that we have a bot which will give us information about our model and all the other information about microplastics, their effect, and how does our model work. Now, let us look at the mock data representation part of our website. Microcontroller sends the data. The server, our website shows real-time detection of microplastics. Our live data is presented in the form of graphs, charts for simplified understanding. Not only they show concentration of the particles in the sample but also calculate possible concentration in larger body of the same sample. As you can see here, how it is representing the data collected from the ML model. Model shows comparison between concentration of microplastics in the given sample with similar samples trained and tested on our model, as well as available data resources. We visualize future potential risk on humans and animals on consumption of microplastic contaminated in water. For more details, we can add more data and infographic diagrams in this website